So this is CPCB monitored emissions. CPCB had funded us a project, a research project to investigate whether plastics can be used for energy recovery. And we successfully demonstrated that from plastics we can generate syngas or combustible gases, which can then be clubbed with gas generator set, gas gen set, and can be used for electricity generation. Basically, we have a very high volume reduction technology. Less than 1% of inerts would be remaining in the waste. If we have 100% organic waste, the volume of the waste, the volume of the ash that will be remaining will be less than 1%, which is very, very high volume reduction. Waste is emerging as an alternate fuel, replacement of fossil fuel. For example, plastics. If we consume 1.5 kilowatt per kg of plastic waste, we can generate around 2 to 2.5 or up to 3 kilowatts power per kg of plastic waste, which is surplus. So this is CPCB monitored emissions. CPCB had funded us a project, a research project to investigate whether plastics can be used for energy recovery. And we successfully demonstrated that from plastics we can generate syngas or combustible gases, which can then be clubbed with gas generator set, gas gen set, and can be used for electricity generation. And the pollutants were way below the CPCB limit set by CPCB. And the dioxin furans were also based on the least count of the machine. So machine could not detect below that. And this was all done by third-party agencies appointed by the CPCB. So this is the first plasma system that was installed in Goa Medical College as a demonstration system funded by DST. And on the left hand side, you can see the letter issued by CPCB indicating that the technology has been adopted in the Gazette of India. We are very happy that this technology was formally accepted as one of the technologies for waste disposal, biomedical waste disposal. So what are the Salient features? Basically, we have a very high volume reduction technology. Less than 1% of inerts would be remaining in the waste. If we have 100% organic waste, the volume of the waste, the volume of the ash that will be remaining will be less than 1%, which is very, very high volume reduction. And it has very low footprint because the plasma, because it's a very high heat source and very high heat flux is provided. So the volume of the chamber and the footprint is very, very low. It also leads to very high preheating, very fast preheating, which results in saving of time. And it, because the thermal plasma is a UV source also, apart from very high temperature, it sterilizes everything within the chamber. It avoids carcinogen possibility, and it is a green technology. It runs on electricity. So if we have a renewable energy supplying energy to this, it can be a purely green energy and it can be used for carbon credits. See, one of the major things that this technology, which is a proprietary technology of the Institute for Plasma Research, is that we don't supply any gases. There is no plasma gen gas provided in this. So we do not have a water cooled torch. We do not have a gas being supplied in the plasma torch. So here what happens is that the pollution is less. In conventional systems, if you provide air, you will generate a lot of NOx emissions. Here, because we do not supply extra air or any extra gas from outside, the volume of gas is pretty less. It's only if 1 kg of plastic is there, it gets converted to the meter cube of gas it would be, and that's the only thing. So the resultant gas handling system is also less. So from that perspective also the system is compact. So there are several types of waste that can be treated using this technology: biomedical waste, plastic waste, cotton waste, agro waste, floral waste, petrochemical waste, tannery waste, all organic waste, and preferably dry because it consumes energy. Plasma otherwise does not have any issues. if it comprises of say 20% moisture or 30% moisture also, because plasma is the energy or heat will get spent in vaporizing the water. So it is better that the water is dried out first and then be efficiently treated. Yeah, so these are prototype for solid waste was installed in Gift City as a first smart city demonstration project, and it was a point 0.2 TPD plant, and it worked for around 3 to 4 years. Now the expansion plan is going on. So here, waste as an alternate energy source is being taken care of. So these are emerging, waste is emerging as an alternate fuel, replacement of fossil fuel. For example, plastics. If we consume 1.5 kilowatt per kg of plastic waste, we can generate around 2 to 2.5 or up to 3 kilowatts power per kg of plastic waste, which is surplus energy. And there are also possibility of plastic blended MSW, like for example RDF. So RDF can be appropriately blended in such a way that the average calorific value of the waste is 3,500 or 4,000 kilocalories. So in that case, it will become surplus energy. So it will be more than the break even, and that's how it can be made sustainable. Other ways of making it more sustainable is to use low cost energy such as wind energy. The wind energy is right now very, very cheap even in comparison with the solar energy. So here we have demonstrated for DRDO, then we have demonstrated for one of the petrochemical companies. So these are certain data based on what we had conducted. We could generate very good syngas from the petrochemical waste, which is a very good thing. And so that this also becomes possibility for hydrogen production. So we have also installed one system at CSM CRI lab, Bhavnagar, experimental system for disposal of solvent waste. And this is they all try to conduct all these kind of studies to dispose all different kind of solvents. This is an interesting slide where we were approached by Varanasi Temple Trust, and they had indicated that the floral waste, let us say bilipal and flowers, was around 4 tons per day. And the Kashi Vishwanath temple alone was generating around 2 tons per day of floral waste. And because this is pious waste, it was not thrown in dustbin, it was being thrown in Ganga. Now the scenario has changed. They have adopted eco-friendly measures. Maybe I understand it is composting technique they have adopted. But our proposal was a little bit different with a sentimental approach. So what we had proposed is the floral waste has some moisture. So here, if you see the flower waste is first, there is the flower waste, water is removed, and then the flower waste, which has some moisture, is fed into a rotary dryer. Now this rotary dryer is fed with hot air, which is extracted from the plasma system. So this dried floral waste is fed into the plasma system, which leads to the generation of hot combustible gases. And these hot combustible gases are then, after cleaning, they can be sent to crematorium. So imagine that a person is cremated using the flowers and offerings made to the temple. So that is something which has a sentimental connection with the public, and therefore we had proposed it so that it also caters to the cremation requirements in the local Varanasi region. And of course, the high temperature, when it comes, these combustible gases, when they come out of the chamber, they are at very high temperature. So we use the heat and extract the heat out, and we use them in the rotary dryer. So this also reduces the energy consumption required for plasma technology. Yeah, there was an option for hybridization where we had proposed solar cells on the rooftop. So this was just an example. So we are not specifically addressing one thing, but this is just for holy places that plasma gasification plant for floral waste can result in very good business model. There are social selling points for this. That it was addressing Swachh Bharat, and then it was also addressing the Clean Ganga option, and it is 100% make in India. Nothing comes from outside. Every small component of this system has been made in India. Then there are waste tires. As you can see, the tires comprises of steel wires, and it also comprises of a lot of carbon black. So when we do the plasma gasification, we can generate steel wires and we can also extract out carbon black, and we can generate combustible gases. So there are syngas, there are stainless steel recyclable as scrap. It can also have residue or ash. It can be used in cement plants and roads, and it can be used for production of chemicals. Sulfur can be used for production of chemicals. So this is just a slide on what do we do. We interact with industries, we interact with entrepreneurs, and they come up with their ideas, or they come up with the requirement that they want to do XYZ R&D to develop a specific project. So we do technology development, application development, feasibility studies. We also do contract research. Somebody wants to study whether their something is feasible or not. Then we do equipment development and supply, but this is only for those equipments which are commercially not available. We make customized systems as required. We do technology transfer licensing. We also do scientific and technical consultancy. And we also run a job shop for demonstrating that technologies developed by us are feasible on a large scale. So we regularly run a job shop where the benefit industry sends their job to us. We do the treatment and hand them back on a nominal fee per kg basis. And we have established a technology business incubator, which is named as Plasma Tech Innovation Foundation. And we give access to all the incubators to the state-of-art infrastructure as well as the expertise available with the Institute for Plasma Research. Yeah, so there are several technologies. I'll not go much into details. We have worked from outer space to deep geology, everything coming in between. So now wherever plasmas are beneficial, we are ready to work. So these are small various systems that we have demonstrated at different parts of India. We have supplied these kind of systems, and the red dots, as you see, are our technology transfer partners. And there are several other systems and projects that we have executed with others. So these are our technology transfer partners. So these are our clients. As you can see, these are national and international clients who have worked with us on sponsored basis. Yeah, so our purpose of establishing the incubator is to make the technology roll out from the lab to the industry. It also facilitates that sometimes there are only capabilities to be proven. So those cases where the Plasma Tech Innovation Foundation support these kind of causes, somebody comes with a bright idea, we are ready to incubate, and it has to be through a process. So if anybody is interested in setting up a startup idea, we'll be definitely would like. So interested people can always email it to us at ptts@ipr.res.in and technology@ipr.res.in.